In this segment, we'll find the derivative of a function by an example by using the definition of the derivative of a function. So the example which we're taking is of this particular function right here, which is 7x cubed plus 5x squared. And what we want to do is we want to be able to find the derivative of this function. So we know that from our definition of the derivative of the function is given by a limit of h approaching 0, f of x plus h minus f of x divided by h. Some people might be using delta x for h. It's the same thing, so there should be no confusion here. I'm using h just because to keep it simpler. So if we want to be able to find the derivative of this function now, what we're going to say is that f prime of x is equal to the limit of h approaching 0, and we have to calculate the function at this value of x, which is x plus h. So that'll be 7 x plus h whole cube plus 5 x plus h whole square minus the value of the function at x, which is 7x cubed plus 5x squared itself, and we divide it by h. And as you can see here that we have to somehow now be able to use the formulas for expanding x plus h whole cube and x plus h whole square. So just to recall, a plus b whole cube is a cube plus b cube plus 3ab times a plus b. And if we expand this, we get a cube plus b cube plus 3a squared b plus 3ab squared. And then the formula for a plus b whole square is nothing but a squared plus b squared plus 2ab. So we're going to use these expansions of these formulas here to be able to calculate the value of this, and if we expand it, we'll be able to calculate the limit. So what we have is that our f prime of x will be equal to the limit of h approaching 0, and we're going to expand x plus h whole cube, so we get 7 x cubed plus h cubed plus 3 x squared h plus 3h squared x. Then we expand x plus h, we get to 5. Then we get x squared plus h squared plus 2xh. Then we're going to subtract 7x cubed plus 5x squared from here. So that's in the numerator. In the denominator we have h. So having said that, this will be limit of h approaching 0. And let's see what we get in the numerator. We get 7x cubed plus 7h cubed and so on and so forth, which I'm writing here. So now, since we're seeing here what we get by the expansion, we can see that 7x cubed cancels with 7x cubed, 5x squared cancels with this 5x squared. So let's look at what the terms which are left over in the numerator are, which are these quantities. And now what we can see is that, hey, if we divide the numerator and denominator by h, I'm going to get 7h squared here. I'm going to get 21x squared here. Then I'm going to get 21hx here. Then I'm going to get 5h here. I'm going to get 10x here, and I'll get 1 in the denominator. So that does not need to be taken care of. Now, as you can see here, that is, as h approaches 0, this approaches 0. This one is 21x squared. There's no h term there. This one will approach 0. This will also approach 0. And this one will stay 10x. So that gives us 21x squared plus 10x. And that is the derivative of the original function of 7x cubed plus 5x squared. And that is the end of this segment.